Welcome to the Alain Guillot podcast, a podcast about life, leadership, and money matters. Our guest today is Thor Hanson. Thor is a conservation biologist and author. He has published 4 books for the general public and 1 children's book. And he has also contributed to a range of periodicals and other media. Today, we will speak about his latest book, Hurricane, Lizards, and Plastic Squids, the fraught and fascinating biology of climate change. Thor, thank you so much for joining us today.
Welcome. You're welcome. It's very nice to be here. Thanks for having me on.
So, Thor, can you tell us a little bit about your life? How is it that you became interested in biology? Is this the thing that you were always attracted to, or is this an acquired taste?
I was the kid who had, the pet snakes and the lizards and all of that sort of stuff. So I've always had a love for the outdoors and for nature. But I think it really became a career for me when I went away to college to a place that in Southern California that was very developed. And I came from a place that was relatively rural. And I saw how human activities had almost erased the ecosystem where I went to live. And it awakened in me this passion for conservation. So not just to know about the natural world, but to try to help it.
Well, I'm going to confess something to you and to my audience. When I was a little kid, my father gave me a BB gun. And I used to live in a neighborhood in Colombia. And I took my little BB gun and I started killing lizards in the streets. And of course, nowadays I feel so ashamed of it. And then when I was a teenager, some family members took me hunting in the jungle and I killed an iguana. And I was so horrified of seeing that dead iguana that I had never, ever pick a gun again in my life. But yeah, that's my story. That's as far as my life with fauna and the environment goes. Other than that, I have been an urban animal the rest of my life.
But an experienced lizard hunter nonetheless.
Yeah. Okay. Well, tell me how you went into the study of biology. That's what you study, I assume, since you have written 4 books about it.
Yeah, absolutely. So I studied then ecology and writing as an undergraduate, and then my path really went towards the sciences. And I went on and got a master's degree in botany, studying plants and so on, but also trying to keep a rather broad perspective always, because there's a real tendency in higher education to specialize into one narrow field, which is important. But I've always valued the sort of broad view and tried to find research and programs that connect a lot of different specialists, so a lot of interdisciplinary stuff. I went on and did a doctoral degree in a joint program between the University of Idaho and a university down in Costa Rica, and traveled back and forth and worked with a lot of different people doing research in these very different environments. That was quite a rewarding doctoral program. So I've always been interested in the natural world and trying to take that broad view, working with collaborations to bring a lot of stories together.
Did you learn some Spanish while you were in Costa Rica?
Poquito.
Okay. So moving on then, what is it that attracted you towards sharing your experience in writing with a broader audience? Because as a scientist, most scientists write for other scientists, but you decided to write for us regular human beings.
Yeah, absolutely. I got sort of a little fed up maybe with how many fascinating stories and discoveries I would see and read about in the scientific journals or talking to colleagues that never made it beyond that audience. And I became really interested then in this idea of the storytelling of science, because science is full of stories, but too often we're so busy as scientists writing our papers and doing our research that we don't have time, or in some cases, maybe not the interest, to try to get beyond that audience and tell everybody what we're learning. And so I've really spent most of my time in the last 5-10 years focusing on books and articles for a popular audience, trying to take these stories broad.
And okay, so could you mention some of the titles that you have written for? And in addition, the children's book as well. I mean, that sounds like such a novel thing to do, to write a children's book, but you have to have a heart for it as well. Do you have any children yourself?
Yes, that's the way it came about. I have a child who's now 12, but when I wrote that book, we were in a period of time where nearly every conversation in the house had to rhyme. And so I started writing rhyming stories for him. And one of those we ended up being published as a children's book. So that was a lot of fun to do. And also, of course, based in natural history as well. So the same sort of idea, but for an even different audience. And then in my other work for older children, if you will, older kids and adults, I've focused on diving deeply into particular topics and seeing where they lead. So I wrote a book all about feathers, their evolution and natural history, but also how people have co-opted feathers for many of the same reasons that they evolved in nature, from color to insulation and so on. And then I wrote one about the evolution and natural history of seeds and how deeply connected we are to seeds, not just for food crops, but for a huge range of uses and cultural connections. And then more recently, I did one on the great diversity and importance of wild bees in our world, their evolution, and then also how deeply tied we are to these very special insects.
Okay, and now this book, Hurricane, Lizards, and Plastic Squid. What was the thing that told you that you had to write this book?
Well, it's a great question. I began my career in biology in the early 1990s. I actually got my diploma as a young scientist on the very week that they met for the first, or the Earth Summit in Rio, and signed the first real international treaty on climate change, sort of marking a transition from when it was more of an academic topic to something that the people writ large were very interested in and concerned about. And so it's always been in the background for all of these projects that I've done. And I've seen it rise up to the fore in many research settings, again, where you think you're going to be studying something, but the conditions have changed because of climate change, and you end up studying something else, or it's impacting your work and results in unexpected ways. And I began to be frustrated by what we all think of when we think of the biological impacts of climate change. I think we all picture that poor forlorn polar bear stranded on an iceberg someplace. And I just want to look beyond that polar bear because I know there's so much going on. And yet too often the conversation about climate change biology stops with that image. And yet there's this huge diversity of responses going on in nature that are really at the heart of any climate change scenario, because it's not so much the change that matters, but how plants and animals respond. And it's the sum of those responses that are really going to determine the future, theirs as well as our own. Wow. So that sort of led me to write that book.
Okay, well, before we embark in this climate change, there have been other previous climate change in the history of our planet. I wonder if the dinosaur disappeared not so long ago, and there is something, I saw a movie called the Ice Age. So, I don't know much about it, but I do know that there have been other changes in the planet, and we as humans, we were not there to contribute to those changes. So why were they climate change before, and what is it about this one that is human-made that is different from the previous one?
Oh, it's a really great question. And we can learn a terrific amount by studying previous climate change events. And what we look at when we go back in time, looking at fossil evidence and so on and so forth, is you see these abrupt transitions when they happen, are accompanied by huge biological upheaval. Oftentimes many extinctions or great changes in habitats and where species live, all of these things you can see playing out in the fossil record. And those changes in the past oftentimes occurred over larger periods of time, sometimes rapid, but one of the most important features of this modern climate change event is how quickly it's taking place. And that is due to the rate at which we have added fossil fuels to the atmosphere, carbon dioxide, methane, other gases from these long stored fossil fuels, which it's important to remember that there is a natural carbon cycle going on all the time. We're participating in it right now. You and I are both doing it when we breathe, in that we are exhaling carbon dioxide. The energy that fuels our bodies comes from the plants that we eat, or the meat that we eat, which comes essentially, the energy still traces to the plants. It's fixed from the atmosphere, carbon dioxide drawn in through photosynthesis and fixed into these plant starches. Carbon dioxide puts the carbo in carbohydrates. Think of it that way. So all of that comes into us. We cycle through it. The only reason that we're having this discussion is that not all plant material breaks down, right? A lot of it rots, some of it we eat, and so on and so forth. That all cycles through steadily. But sometimes plant material gets buried either on the ocean floor, or it gets buried in peat bogs and other marshy places, and then covered up with sediments, and over millions of years turned into coal and natural gas and petroleum, these sorts of things. Those are all ancient plants that didn't rot. And because they didn't rot, they stored that carbon dioxide that normally would have rotted and gone into the atmosphere right after they died. They stored it in the rock. And so when we draw all that out, as we have over the past 150 years, and burn it, we've released millions of years of stored carbon all at once, and just overwhelmed the natural cycle, so that we see all the consequences unfolding with the rapid, from a geological perspective, very rapid change in overall temperatures of the planet and the climate implications that drives.
So then the major difference from this climate change to the previous one is the speed that it is happening. And while in previous climate change, it happened gradually and species had time to adapt to one temperature or the other. Now species are not having that amount of time, and some of them are suffering.
Time is a huge factor. Yeah, the quicker it happens, the less time there is to adapt. And so when we look back at previous examples, the ones that were the quickest were the ones with the biggest implications, right? And right now we know we're in a very fast change. So the speed of it and the source of the change being human driven, those are the things that set this apart from the previous ones. And then the other thing that sets it apart, of course, is what you pointed out. We weren't there to witness those. We weren't there to try to survive them. So the challenge for us to try to get through this rapid change while holding on to the lifestyles, the standard of living that we either enjoy or aspire to, those are the things that will be a big challenge for us moving forward.
Wow. One of the things that I like about your book, and practically any biology book, is when I'm reading it, I will Google all the species that you are talking about. For example, the brown pelican. I don't know what it looks like until I go into Google image. The squid, I don't know how to pronounce it, Humboldt squid, the anole lizard. I have no idea of these guys other than, I don't see them in the city, so I don't know what they look like. So I love how this broadened my knowledge of the animal kingdom. But you said that you wouldn't talk about the poor polar bear dying of hunger in the Arctic. You had many other examples. Could you bring forward some of the other examples that you have written about?
Sure. Well, let's take one that also happens in the Arctic. Literally, if you could see over the edge of that iceberg, beyond and behind the big fuzzy bear, you might glimpse these beautiful little seabirds called little auks or dovekies that feed along the edge of the pack ice in the Arctic. That's a place where there's a lot of plankton, where the water is the pack ice is melting, and it creates this area that's rich in plankton, and the birds eat the plankton. So that's been a marvelous strategy for these little dovekies for thousands of years. But now that the ice is retreating, they're in a bit of a bind because they breed on these islands in the Arctic. And as the pack ice gets farther and farther from those islands, the dovekies have longer flights to make to get to their feeding grounds. And they have to bring food back to their chicks. So you can imagine if they don't have time to make those journeys, if it becomes too far, they can't feed their chicks and the population collapsed. At least that was always the prediction. But a few years ago, when a scientist named David Gremillet and some of his colleagues were on an expedition to an archipelago in Russia called Franz Josef Land, where dovekies breed, they found something different. It was a remarkable transition that had occurred unbeknownst to any of us in our labs, down south here, making our calculations and predicting the demise of dovekies, in that when they got there and they radio tagged these birds and let them go, then gathered them again and took their tags and got the data, what they learned was that instead of flying an hour or more, which they'd predicted to reach the edge of the pack ice, the birds were in the air less than 4 minutes. And then they had to think, well, what on earth is going on? Where are these birds? And they found them at the mouth of the very fjord on this island where the nesting colony was. It was a new feeding opportunity had arisen right on their doorstep, where meltwater from the island glaciers slammed into the dark currents of the Arctic Ocean. And when you have that sort of a transition between two kinds of water, plankton hit it as if they're running into a brick wall, like driving into a wall, and it stuns them or even kills them and creates this curtain of plankton across the mouth of the bay. So the dovekies were able to pivot from pack ice to this new opportunity. And rather than finding these starving and declining populations, they found that indeed the dovekies were thriving on this new food source. Now, it's not a solution that will last forever because the island glaciers are melting as well and will be gone in 100 or maybe 200 years. But it buys the dovekies time. It buys them time to hopefully find another fix for their predicament. And it shows that they have what we call in biology plasticity, the ability to bend or flex in response to new conditions. And that is a critical capacity in this time of rapid change.
Okay, so those are thriving. Can you talk about one species that is suffering then?
Oh, a species that is suffering, certainly. Well, again, I think it's helpful to think of this idea of plasticity and flexibility in terms of change, because some creatures have it. The dovekies were able to pivot their behavior, right? Other species are able to even change their bodies, like the squid you mentioned, responded to hot water in their environment by becoming smaller and more efficient in how they use the resources. They survived by getting small, so they can even change their bodies. But other species that lack natural plasticity, that inherent ability to adapt, are the ones that are in a fix when things change. And I'll give you an example from right here near where I live in the Pacific Northwest, where we were exposed to heat extremes this past summer, heat waves that were record setting. If you will. And at low tide, our beaches in places were 120 degrees Fahrenheit, which is very, very hot and beyond the comfort zone, if you will, for the creatures that live there. So the mussels and some other intertidal creatures, many of them baked alive in their shells, right? They had no way to respond to something so different. So there's one example. Another one I would give you would be a lizard that lives in the American Southwest, the western fence lizard, which you might think, hey, it's a desert lizard. It should be well adapted to a warm future. But in fact, what scientists have learned is that these lizards Well, they respond to hotter and hotter weather the way they always have. They go under rocks to stay in the shade and stay cool. But if they spend too much time in the shade, they don't have enough time to feed. So as the temperatures rise, the calories taken in by the lizards start to go down. And if that gets to a critical point, which it has in many populations now, the female lizards can't build up enough energy reserves to reproduce.
Wow.
So temperatures go up, lizards stop breeding, and you can see the end result of that.
Wow, that's so sad. That's so sad. Okay, well, those are climate change adaptation that are happening slowly. All the plants and animals are adapting as is happening in real time, let's say. I wonder if you could share some instances where we humans, we are destroying the whole habitat, for example, in the Amazon, that we are just burning and killing all those plants in order to raise cattle. Or
Yeah, that's a really good question, because it brings up the point that in addition to this great stress of climate change, we are stressing the natural world in a lot of other ways. And I think it's instructive to consider that just a few years ago, there was a popular book called The Sixth Extinction, pointing out how we're in a largely human-caused extinction event where a lot of creatures are disappearing, and climate change plays a big role in that. But also 30 years ago, there was a book called The Sixth Extinction by another author, and the phrase climate change does not appear in the book. So even before we recognized how serious climate change was, we considered this period of time a huge extinction event because of the habitat loss, like you mentioned, the destruction of forests and other habitats around the world, pollution and human population increase, and all of these things that we have done, overfishing and hunting, and the rapid use and expansion of our population has already put creatures under stress. And now climate change is what people will call sort of a threat multiplier. It makes all of those stresses that much worse. So I think that's a marvelous point to raise. And if you want an example that I use from the book, it actually draws in history as well. And it's the example of Joshua trees, which are a desert yucca plant that the famous band U2 named one of their albums after, and so forth. It's a very distinctive looking, crazy armed, tall yucca in the American Southwest. And the yucca trees are disappearing. There is a Joshua Tree National Park now that is at risk of having no Joshua trees in the future because they aren't dispersing. You have the adult trees and then a few little ones around it. But as the climate change, they can't get to the places farther away that would be suitable for them. Wow. Yet if you look over their history, if you look at fossils, their populations have moved up and down in the Southwest through previous climate change events. So why aren't they moving now? And the reason has to do with a creature that's been extinct for 14,000 years. The Shasta giant ground sloth, if you go and look at its dung piles, which are still there, preserved in that dry desert air in the caves where it used to live, they're full of Joshua tree remains, seeds and fruit remains and all of these things. So that creature was the long distance disperser for Joshua trees. And the key to this story is that 14,000 years ago, it is believed that human hunting drove the Shasta giant ground sloth to extinction. So what's really intriguing about the story is that even things we did thousands of years ago are having repercussions all this time later. And so you just multiply that then by all of the impacts we're having now, and you can see how the consequences amplified by climate change create an almost chaotic situation in nature trying to predict how species will react.
Talking about reaction, then how are we humans reacting? I have been at a few demonstrations right here in Montreal. I have been marching against all these climate change that is happening. I know that our Prime Minister here in Canada, Justin Trudeau, he wants to impose a carbon tax in order to reduce the amount of carbon in the atmosphere. But then we have a opposing government on Alberta who they make their living by selling oil. And I assume the same thing goes into the United States, that the states that have depend economically from the sale of oil, or they are opposed to those kind of carbon taxes. So I wonder, how are we evolving and responding to all this climate change? Are we going to fight against each other until the planet is dead, or are we going to come to our senses and somehow at the last moment, like in a Hollywood movie, save the planet?
Yeah, who's going to come in and save the day? I think this is a great question. Of course, it's what a lot of it boils down to for us. Two responses for you. The first one that I think is important is to see how our responses as a species really reflect what we see in nature. And I'll give you one very current example, and that is Hurricane Ida, which slammed into New Orleans here in the United States, and then the remnants of it swept north and caused other damage. But when it slammed into New Orleans, that coastal city down on the Gulf of Mexico, the seawall protecting New Orleans, which is new, they built it since Hurricane Katrina, it held fast and protected the urban area from that huge storm surge. So it didn't flood. And that is an example of adaptation. You know, our species adapting, staying in place and adapting. And we see that in nature with, creatures that are adapting and staying in the same place, like the dovekies that change their feeding habits. They're staying right where they are, breeding in the same location, but they adapted. The other thing we see commonly in nature is movement, or another major theme is movement. Species that can move will look for the conditions they're used to. You mentioned the brown pelican earlier. They are moving northward as the planet warms. They're finding that these places in the north that used to be too cold are now more and more habitable for them. And we see this in thousands of species. So adaptation and movement. Well, let's go back to New Orleans, and we see that the seawall held, but it's protecting an urban population that is still 20% smaller than it was before Hurricane Katrina hit that city in 2004 or 2005. So what we see there is an example of movement then. Tens of thousands of people left New Orleans, never to return, because to them it had become uninhabitable due to climate change. And so we see the same responses playing out in our species than we see in nature. And the key difference for us is that we have the ability, if we so choose, to change the habits that are bringing climate change about in terms of our activities releasing carbon into the atmosphere. And in that regard, I emphasize the importance of personal action, in that what we really need in this situation is a cultural shift in our relationship to energy, how we produce it, where it's coming from, but also how we use it as individuals. And that's where each and every one of us has a role to play, because our decisions will help change the culture, because a cultural shift is by definition the sum of the individual actions and attitudes of its people. And just as we can look out in nature and see how the responses of individuals determine the fates of populations and species and ecosystems, the same thing ultimately will be true for all of us. We need to change our own attitudes and drag the culture and ultimately the politicians with us. I was on a radio show not too long ago, and the woman who spoke before me was a political reporter talking about how the climate-driven events and extremes of the past 6 months or so had begun to really change how the public perceived climate change as an immediate threat. And she predicted that it wouldn't be long before that public upswell would change the politics of climate change. And that is very much what I'm talking about, how it has to come from the people. When our attitudes change, we drag the culture with us. We can't sit around waiting for leaders to do it for us. We will drag the transition from the ground up.
Wow, but it is an an amazing battle because let's say climate change activist Greta Thunberg came here to Montreal, and I have never seen so many people trying to protect the environment and protest against climate change. Yet a few hours later, well, you see all kind of consumption going on in the same park, people drinking beer, throwing things around, the billions of dollars in advertisement campaigns on buying the latest trend or whatever. And it's just, and just like governments are fighting against each other, we consumers, a set of the population is trying to, I don't know, use recyclable everything, while the other part of the population is just creating garbage without any conscience of the damage that they're doing. So I guess what you're saying, it will happen eventually. One team will come to the senses and join the other team, but would it be too late?
I know, and that's the question we all wish we had an answer for. Will we make this transition in time? There's a marvelous book called Don't Even Think About It by a fellow named George Marshall, who has spent his career campaigning for climate change policies and was so frustrated with the lack of action that he put things down for a year and did some research trying to understand why climate change is such a difficult challenge for people to overcome. And it, people want to put it out of their mind, even if they agree with, the climate science and they believe it's important. It's such a big, overwhelming, abstract problem. We're not very well equipped to dealing with those problems. We do a lot better if there's a rhinoceros charging towards us or something and we can jump out of the way. We react really well to immediate threats, but abstract threats are more difficult. And I think one of the things that it's sort of a double-edged sword, but as we see climate change impacting our daily lives, which I think people really saw over the course of this past summer with the massive storms and floods and heat waves and so on, that makes the threat a lot more immediate. And I believe that is going to help speed up this transition for all of us, because we do well when something is imminent. But it's been very difficult to communicate about climate change when people could still perceive it as a problem isolated on an iceberg with a polar bear far away someplace in the Arctic. I think we're starting to see it enough in our own lives that it will help drive the change. And I hope, as you do, as we all do, that it's fast enough.
Well, last question then, other than voting and being informed, what are other steps that regular people can take in order to reduce the damage that we're doing to the planet?
Great question. I think it has to do with daily decisions in energy use. And it's what I talk about, this shift in our relationship to energy. And I'm going to tell an old joke, if you'll bear with me, but I think this gets at the question better than any other analogy. My family is from Norway originally, and there are a lot of, in the States and I'm sure in Canada too, Norwegian jokes that Norwegian immigrants tell about each other. And so this is one from my family where there was an old Norwegian farmer named Ole who had lived a great life. His family, he was just beloved as the leader of the family. And when he was dying on his deathbed at the family farm, everyone gathered in the bedroom to say goodbye. And Ole looked up and he said, "Is Lena here?" And they said, "Yes, Lena's here. We're all here, Ole." And then he asked if Lars was there, and they said, "Yes, we're here in the bedroom with you, Ole. Everyone is here." And he started then to go through all the members of the family. He was asking about Regina and Russell, and finally, this, they could see he was getting upset, and they said, "Ole, the whole family is here with you in the bedroom." And he said, "Well, then why is the light on in the kitchen?" And I love that joke. The humor is gentle. The humor has to do with the frugality of the Norwegian farmer, but it also points out that not too long ago, energy was so precious that you could make a joke like that. In the United States, we had what is called the Rural Electrification Act. It was signed in 1936. So less than a century ago, electricity came to the rural areas. And that people perceived it as a precious resource, and you would never leave a light on in another room. And I think we all have to think about energy a lot more like old Ole does, right? Where you start to perceive it as precious. And when we can do that, we'll find a lot of subtle habits changing, and it can help drive this transition to a brighter future.
Well, yeah, could you tell us one more time the title of the book and where can the listener follow the work that you do?
Sure. Yes, the book is called Hurricane Lizards and Plastic Squid, the fraught and fascinating biology of climate change. And my website, where all of these sorts of things are posted, is thorhanson.net.
I'm going to use that joke tonight in a group reunion that I have with my friends. Thank you very much.
You're very welcome. Thanks for having me on. It was fun.